To remind you, we left off here, and we're going to kind of go over both graphs with similar terms. So biotic potential basically means a population can grow indefinitely with no environmental resistance at all. Intrinsic rate of increase is describing that growth in a sense. They use R to describe that. It's the rate at which a population can grow with unlimited resources. So it's kind of the same definition, but it's talking about the growth versus the possible growth without resistance. And we already learned somewhat. Last class I told you to write some things down. What do we call this curve? All right, what do we call this? Exponential growth, which is what shape? J-shaped curve, okay? So now on this slide, right, when you see a J-shaped curve, you know it's exponential growth. You know it is expressing intrinsic rate of increase, or R, yes? And you know it's expressing a population's biotic potential, which is growth without any resistance. Okay, all of those things can be related to a J-shaped curve. Then we've got what we talked about, which was logistic growth, which is, what kind of curve is this? S-shaped curved, yeah, which is steady, stable growth, which is what happens when a population reaches what we call the carrying capacity, which is limits to being able to continue to grow, limits being any resource, other organisms, or anything of that source. So here are graphs. One shows irregular population growth, one shows stable, one shows cyclic. And obviously, even if I didn't give you this on a test, you should be able to write the line for the carrying capacity by viewing the patterns of the population and then erupt. You should also be able to try to come up with an explanation as to, like, let's say here, who could give me an explanation for erupt growth? With erupt growth, and you mentioned baby boom, yes. Somebody mentioned natural disaster. That could be an explanation for this drop. Try to think of others.
Introduction of another food source.
Good. Like somehow the environment is supplying resources to their population. Would describe which growth?
The interrupt growth.
Good. Like maybe, yes. Yeah. Or lack of something to control the population. Lack of predators, that's another one. You could say that if we're talking about any kind of organism and there's a migration pattern and a big, that's totally true too. Good. And I mean, you got to be able to recognize, where would my carrying capacity be? Let's say, right, let's do cyclic. Where do you think the carrying capacity would be?
Kind of right up top, right?
So you're saying up here? We're drawing the carrying capacity. You guys are saying somewhere around here. It's kind of obvious because the population exceeds the line and then declines after that. It could be anywhere around there, and that's true, okay? Good. Now I'm going to show you another set of graphs. By the way, these terms, they're terms. Irregular, no patterns of growth or decline. Stable is along the carrying capacity. So like literally a carrying capacity would be right around there, right? Cyclic shows patterns of something happening that's causing the population to drop and decline, and then erupt, like we explained, just a weird increase. All right, so this is another thing you can have is a graph, and it's going to be labeled, and you have to be able to explain different parts of the graph. So let's start with, or you pick anywhere you want. Pick something that you think you could describe. Yeah.
The line is carrying capacity.
This line is carrying capacity. What letter do we use to reference that? K. Don't forget that. Add the letter K there to your notes. I'll do the same. Who could describe another line? Yes.
The tail end kind of looks like cyclic growth.
Okay, like this?
Yeah.
Good. So actually there's nothing describing that whole growth, but yes, if we circled this, we could call this whole thing right here. Let's say we did that. A cyclic growth, right? Maybe not so much here because we're not seeing the rise. So let's actually cut it and do that and erase this part. Good. What else? Peak? Good. Where's that? At the top. I actually have a vocabulary word to describe that. At this peak, what happens to the population? So we have rise, 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 and then you said what?
That they start to die.
They start to die. What do you think led to that?
Lack of resources.
Lack of resources. So too many people, not enough resources. What word is that?
Environmental.
Good job. Overpopulation. So yes, peak is another word. There's a lot of things that you could say that I'm not saying that actually are true as well. Overpopulation. The population grew to the point where it exceeded its resources, so it declines. What do you think this line is here, right here, coming down right here? Decline. What about this dotted line? What's happening to the population here? Let's pretend I went here. What? Yes, death. Good job. What about right here? Right here. Look what's happening. Zoom into your notes and look. What do you see happening there? Good. It's actually starting to increase again, or recovery, what we call it, stabilizing. And then what do we call this? What do we call it? Exponential growth. What else? There's a couple words. We just went over them. J curve. What else? Biotic potential. Intrinsic rate of increase. Even a fundamental niche. We could go back. Density dependent limiting factors. So remember that from here on out, we're only going to talk about impacts of growth, death, birth, immigration, emigration, and overall patterns and explanations as to why these patterns happen, okay? Because those things. So these are factors that impact population growth or decline or whatever you want to call them. And the population is dependent on these factors, or these factors are dependent on a population. So it kind of works both ways. What are they? We kind of just talked about all of them when we were describing scenarios for logistic, irregular. Food, resources is definitely an issue. What else? The picture should kind of help you. Disease, thank you. Because a virus is dependent on a population to spread, right? Bacteria as well. What do you think this is? Is that a great GIF? What's happening? Predation, competition. Other organisms in general maintaining the balance of an ecosystem. So those things are definitely density dependent.
Could you be specific and say like human impact, or is that not necessary?
So human, you can start with that if you describe that.
As a part of resource.
Yeah, correct. Okay. And then we've got factors that are not dependent on the population that could drastically cause a decline to the population. What do you think those are? Natural disasters and weather. That's a big one. So natural disasters, weather, temperature, all those mean the same thing. And then what else? Pesticides. Good. That I rarely get that release. Pesticides wipe out a pest population, even a plant population for that matter. And what do you think's happening here? What do you see happening? So fast, yes, deforestation or clearing a forest.